nature has this way of being even more creative than we are. So we have always been surprised by what we see in the sky.
The James Webb Space Telescope wins the double award for the most powerful and expensive telescope ever built. However, the telescope is already justifying the huge price tag by delivering stunning images of deep space that we never could have. In this video, we bring you 15 all-new images taken by the James Webb Space Telescope that shocks the entire space industry. JWST captures Cassiopeia A supernova. Supernovae, or star explosions, are among the most dramatic events in space. The Cassiopeia A, a remnant of one such explosion, is being captured in detail by the JWST. Cassiopeia A, also known as Cass A, is a stellar explosion that occurred 340 years ago. According to NASA, it is the galaxy's youngest known remnant of a massive supernova. Webb's mid-infrared image of the supernova remnant provides astronomers with insight into how such explosions occur. Other telescopes and observatories, including NASA's Hubble Space Telescope and the Chandra X-ray Observatory, have extensively studied Cass A. However, Webb's new mid-infrared images contain a wealth of new scientific information that scientists are only now beginning to unravel. Cass A, according to NASA, can help answer critical scientific questions about the origins of cosmic dust. This is significant because cosmic dust serves as the foundation for stars, planets, and eventually life. Observations have revealed that cosmic dust pervades even the most primitive galaxies in the early universe. Supernovae like Cass A eject massive amounts of heavy elements into space. Because cosmic dust is composed of these heavy elements, it is difficult to explain its origins without attributing some of it to supernovae. But there's a catch. The sheer amount of dust observed in those early galaxies cannot be explained using current supernova observations. Using the James Webb Space Telescope, scientists hope to gain insight into the dust content of Cass A. JWST captures spectacular images of Uranus with its rings. The scientific community has high expectations of the JWST because of its ability to take pictures of objects so far away in deep space. However, the powerful telescope also excels at taking pictures of objects closer to home. It has captured an incredible image of Uranus, revealing the ice giant's ring system, brightest moons, and dynamic atmosphere in great detail. The new image of Uranus depicts 11 of the planet's 13 known rings, some of which are so bright that they blend together. And the fact that JWST's near-infrared camera or NIRCam instrument is sensitive enough to have captured the innermost two of Uranus's dusty rings will astound astronomers. These faint rings have only been seen by two other astronomical telescopes, the Voyager 2 spacecraft, which flew past Uranus in 1986, and more recently the Keck Observatory's Advanced Adaptive Optics. When Voyager 2 photographed Uranus during its 1986 flyby, it saw it as little more than an inert blue marble with no discernible features. This new JWST image is a stark contrast, depicting a dynamic and changing world. The JWST image was created by combining data from two filters, which are visible as the blue coloration and orange highlights. The representative color image depicts a dense, icy fluid of water, methane, and ammonia above Uranus's small rocky core, which resembles a light blue snowball. Uranus has a unique orbit in the solar system, rotating on its side and tilted at a roughly 90-degree angle relative to its path around the Sun. Because of this tilt, Uranus has extreme seasons, with each pole exposed to constant sunlight for many years before being plunged into darkness for an equal amount of time. It is currently spring at Uranus's northern pole. The image shows the right side of the ice giant brightening at its north polar ice cap, which is facing the Sun. This is the first time scientists have seen this aspect of the polar cap. It is not visible in any of Keck's advanced images. JWST takes pictures of galaxy clusters warping space-time. In Greek mythology, Pandora's curiosity leads her to open a container that releases all of the world's evils and hardships. And we can only hope that the James Webb Space Telescope did not do just that when it zoomed in on a region of space known as Pandora's cluster, using a phenomenon predicted by Einstein in 1915. The new JWST image reveals previously unknown details about the region, as well as the merger of three already massive clusters into an even larger mega-cluster of galaxies. The JWST created a single panoramic image with 50,000 infrared light sources. This resulted in a deep-field image of Pandora's cluster located approximately 3.5 billion light-years away, with an impressive balance of breadth and depth that could revolutionize galactic evolution research. A bright foreground star from the Milky Way is prominent in the image with distinctive diffraction spikes created by the JWST. This is surrounded by bright white light sources that are surrounded by a hazy glow. These are the much more distant galaxies of Pandora's cluster. Interestingly, Einstein posthumously provided the key to unlocking Pandora's box. According to general relativity, objects of mass have an effect on the very fabric of space, warping it. This is similar to placing objects on a stretched rubber sheet and making dents in it. Similarly to how balls of increasing mass cause larger, more extreme dents in that sheet, cosmic objects of enormous mass cause large warps in the fabric of space-time. This curvature can be so extreme that light's path through it is also curved. That is, if light from a background object passes through a body of extreme mass in the foreground on its way to Earth, the background object may appear to have moved in the sky. And this gravitational lensing effect may have additional consequences. The foreground mass object, also known as a lensing object, can sometimes help amplify the light from background objects. This amplification allows the already powerful JWST to see light from distant and thus early galaxies that would be too faint to see without lensing. Background objects can also be stretched as a result of their light taking different paths with different travel times around the lensing object. This distortion aids astronomers in distinguishing between foreground and background galaxies. JWST captures images of very faint galaxies in brand new images. The James Webb Space Telescope team has released a brand new image of the universe. The image depicts distant galaxies stretching into deep space and covering only 2% of the sky as the full moon does. Thousands of galaxies can be seen in the image, the faintest of which are approximately 1 billion times fainter than what the naked eye can see. This is known as a medium-deep, wide-field image. The light from the farthest galaxies has traveled nearly 13.5 billion years to reach us. The image is made up of 8 different colors of near-infrared light, all captured by the JWST's NIRCam, which reveals objects and structures that would not be visible in optical light. Much of this new image was previously unseen in Hubble Space Telescope or other ground-based observatories' observations. The research is part of the GTO program, Prime Extragalactic Areas for Reionization and Lensing Science, or PEARLS. A member of the team behind the image, who is also a professor, said he had never seen this kind of magnificent image before in his over 2 decades of space-related career. He said JWST's images are truly phenomenal, far beyond his wildest expectations. They allow him to calculate the number density of galaxies that shine to very faint infrared limits, as well as the total amount of light they emit. JWST takes peerless, fiery hourglass image. NASA has released another incredible JWST image, this time of a galactic hourglass of fire. The image depicts the dark cloud nebula L1527, and within this dark cloud is a protostar, the very beginnings of the formation of a new star. The image, captured by JWST's NIRCam, shows invisible near-infrared wavelengths of light that have been revealed and translated into colors of visible light that comprise the image's elements and components. A new protostar is positioned about 460 light-years away within an hourglass-shaped cloud of space material that is feeding its growth. This beginner protostar resides within the neck of this hourglass shape, and during its early formation will eject elements that can be seen clearing out and illuminating the cavities both above and below it, depicting what the image depicts as glows of orange and blue boundaries surrounding gas and dust that create this hourglass-looking shape in a now visible infrared view. The image shows blazing colored clouds within the Taurus star-forming region that can only be seen in infrared light, making the L1527 Dark Cloud Nebula one of the best targets for JWST's NIRCam. Webb's images are not only beautiful, but they also provide astronomers and scientists with important information about the birth and formation of a new star. Bubble-like shapes can be seen in the upper central region of the image due to stellar burps or sporadic ejections as described by NASA. The bottom half of the image appears blue as well, as this is where the space dust between the protostar and the JWST is thinnest. The top half is thicker with less blue light able to escape, resulting in pockets of orange-colored regions just above it. The L1527 is a young star, only about 100,000 years old. It is classified as a Class 0 protostar, meaning it is in the early stages of star formation. According to NASA, protostars like these have a long way to go before they can transform into full-fledged stars, which explains why they are still cocooned in a dark cloud of dust and gas. JWST's image of cosmic dust rising from a binary star system. One of the latest images from the JWST reveals a mysterious carbonaceous material surrounding a binary pair that is essential for star and planet formation. The latest image from the JWST shows a binary star called Wolf-Rayet 140 with shells of cosmic dust being ejected into space from the binary system. At least 17 rings are visible surrounding WR140. These dust shells form as the binary star pass close together in their orbits around one another. Each close orbital pass interacts with their stellar winds, which are streams of particles emanating from the stars ejecting the shells into space. The even spacing of the rings indicates that the events that cause the shell formation occur with clockwork regularity once every 8 years. The 17 shells can be counted like tree rings, indicating over 130 years of dust formation. The team strengthened their confidence in this interpretation of the image by comparing their findings to the geometric dust models developed by Yino Han, a doctoral student at the University of Cambridge, which showed a near-perfect match to their observations. The shells seen the farthest away from the binary star have traveled more than 70,000 times the distance between Earth and the Sun at speeds of around 6 million miles per hour. And the team was able to analyze the starlight and study its chemical composition using the JWST's MIRI. This informed them that the surrounding dust is made up of material that is crucial in the formation of stars and planets. However, the origin of this carbonaceous material is still unknown. The team said they now have evidence that WR binaries can be an important source of carbon-rich compounds that enrich the interstellar environment of our galaxy and likely galaxies beyond our own, based on the combined results of JWST's MRS spectra and MIRI imaging. Neptune shows off its rings in new JWST images. The JWST once again strikes close to home as it captures planet Neptune as never seen before. NASA has now released an incredible view of the ice giant Neptune captured by JWST that reveals the planet's rings and faint dust bands in amazing detail. Planetary scientists are already comparing the new Webb image of Neptune to those captured by the Voyager 2 spacecraft during its 1989 flyby of the planet. We haven't seen those faint dusty bands in 3 decades, and this is the first time we've seen them in infrared. However, anyone familiar with the Voyager 2 images of Neptune may be perplexed as to why the ice giant does not appear bright blue in these new JWST images. Well, JWST's NIRCam provides the answer, imaging objects in the near-infrared range of 0.6 to 5 microns. The methane gas that gives Neptune its blue hue in Voyager 2 images actually absorbs red and infrared light, so the planet appears nearly dark in near-infrared except in regions with high-altitude clouds. And Triton, Neptune's largest moon, is the large bright point of light with diffraction spikes that dominates the image. However, if you look closely, you can see 7 of Neptune's 14 known moons surrounding the planet. Triton appears so massive because its surface is covered in nitrogen ice, which reflects approximately 70% of the sunlight that strikes it. Triton is thought to have a subsurface ocean, which is why a new mission called Trident is being planned to visit Triton. This incredible image of Neptune captured by humanity's largest space telescope is a tantalizing glimpse of how JWST will reveal our entire solar system in a whole new light over the next few decades. JWST captures the moment the DART spacecraft crashes into an asteroid. The JWST and the Hubble Space Telescope both captured incredible images of NASA's DART mission colliding with its asteroid target. NASA and the ESA have just released the images, which provide a fascinating perspective on the aftermath of the first successful asteroid deflection test in human history. NASA's Double Asteroid Redirection Test, or DART, intentionally collided with Dimorphos, a small asteroid moonlet orbiting the much larger asteroid Didymos. The mission is part of a strategy to see if a potentially dangerous asteroid or comet heading for Earth in the future could be deflected in this manner. The final stages of the DART mission were live-streamed online, allowing people all over the world to watch the spacecraft approach and collide with Dimorphos. Both the JWST and the Hubble Space Telescope observed the impacts before and after effects, providing astronomers with vital scientific data and giving the intentional crash a new perspective. Before the collision, the JWST observed the site of DART's impact and then continued to observe the after effects for several hours. A bright core can be seen in images and video captured by JWST's NIRCam, along with wisps and plumes of ejected material speeding away from the point of contact. The 8 distinct points that you see are actually 8 diffraction spikes caused by the mirror structure of the JWST. In the weeks leading up to DART's impact, the Webb team had spent weeks researching how to track an asteroid moving through the sky at a rate 3 times faster than the Space Telescope's original speed limit. The asteroid will be tracked in the coming months by JWST's MIRI and NIRSpec. JWST's image of the tarantula. No, the JWST has not started taking pictures of arachnids, but deep space targets. The JWST has provided a spectacular and unprecedented view of the Tarantula Nebula, a star-forming region. A combination of high-resolution infrared instruments on the JWST reveals thousands of previously unseen young stars in the stellar nursery known formally as 30 Doradus. The amazing new detail captured by the $10 billion Space Telescope shows gas and dust in the nebula, as well as distinct background galaxies. Doradus 30, dubbed Tarantula because of its spider-like appearance, can now be seen to resemble a burrowing tarantula's silk-lined lair thanks to the image's superb new detail. The image is the most recent in a series of stunning images released by JWST, which debuted on Christmas Day 2021 and released its first images in July. A perfectly formed Einstein ring was recently photographed. The Tarantula Nebula is located 161,000 light-years away in the Large Magellanic Cloud and is the brightest star-forming region in the local group of galaxies, which includes our Milky Way. Astronomers studying the formation of stars are particularly interested in the nebula. The nebula has a chemical composition similar to star-forming regions from when the universe was only a few billion years old, providing a unique insight into how stars formed in the distant past. Phantom Galaxy captured by the JWST. The JWST has captured a stunning new image of a spiral galaxy that resembles a celestial seashell made of blue and pink gossamer gas filaments. The galaxy known as M74 is shaped like a nautilus's seashell, and its spiral dimensions are thought to follow the Fibonacci sequence. M74, also known as the Phantom Galaxy, is located in the constellation Pisces, about 32 million light-years from Earth. Because of its prominent and well-defined spiral arms, M74 is known as a Grand Design Spiral. It is also directly in our line of sight, making it a popular target for astronomers studying the origin and structure of galactic spirals. JWST's keen vision has revealed delicate filaments of gas and dust in the grandiose spiral arms that wind outwards from the center of this image. A lack of gas in the nuclear region also allows for a clear view of the nuclear star cluster at the galaxy's center. JWST's mid-infrared instrument captured the image, which is sensitive to light in the mid-infrared region of the electromagnetic spectrum. The new image is part of the long-running Physics at High Angular Resolution in Nearby Galaxies, or PHANG's survey of stars, star clusters, and dust within 19 galaxies. PHANG's goals are to find star-forming regions in those galaxies, to measure the masses and ages of star clusters, and to learn more about the small grains of dust that drift in interstellar space. PHANG's has already imaged those 19 galaxies using Hubble's advanced camera for surveys, making JWST's images of M74 ideal for an early comparison between the two space telescopes. JWST snaps amazing pictures of the Cartwheel Galaxy. A stunning new image from the JWST captures the gorgeous Cartwheel Galaxy in never-before-seen detail. The telescope's composite image furthers our understanding of the peculiar wheel-like star system. The Cartwheel Galaxy, 500 million light-years from Earth, is a chaotic galaxy shrouded in hot dust. It also conceals a violent past. Its appearance, similar to that of a wagon wheel, is the result of a high-speed collision between a large spiral galaxy and a smaller galaxy not visible in this image. While the Cartwheel Galaxy now has a cartwheel shape, it was most likely a spiral like the Milky Way before the collision. The collision occurred in the Cartwheel Galaxy's center, resulting in two visible rings that spread out from its impact site. The bright inner ring is teeming with hot dust and clusters of young stars, while the outer ring is home to newborn stars and supernovas. As streaks between the two rings, some of the original spiral features can still be seen. The most recent image reveals what is happening to this galactic acrobat as a result of the collision. To the left of the Cartwheel Galaxy are two smaller companion galaxies, with many more galaxies in the background. While the Hubble Space Telescope had captured images of the Cartwheel Galaxy, the infrared camera on the JWST revealed more stars than could be seen in visible light. This is because young stars are easier to see through dust when viewed in infrared light. JWST captures Jupiter in all its glory. We've seen images of Jupiter before, but none compares with the pictures of the gas giant taken by the JWST. The JWST team has released a pair of highly detailed images of Jupiter that show its auroras around the poles. Both images are composites, which mean they combine multiple images captured by the telescope's NIRCam into a single high-definition image. Jupiter's faint rings, as well as two of its moons, can be seen in the wide-field image. Amalthea is the bright dot on the far left, and Adrastea is the faint dot at the edge of the rings located between Amalthea and Jupiter. The faint dots of light behind the three celestial bodies are thought to be galaxies. The team confessed they didn't expect the pictures to turn out so well. The second image is a close-up of Jupiter, which was captured using 3 different filters to capture the details of its stormy atmosphere, including the glowing auroras. The brightness indicates high altitude, so the Great Red Spot, like the equatorial region, has high-altitude hazes. The numerous bright white spots and streaks are most likely high-altitude cloud tops from condensed convective storms. You may be wondering why the image's colors aren't what we're used to seeing when it comes to Jupiter. Well, the JWST sees the light in the infrared range, not the visible range, so the colors in the two images are not what we see with our eyes. Because the infrared data were mapped onto the visible light spectrum, these images are false color rather than true color. JWST captures the Southern Ring Nebula. When astronomers first saw spectacular images of the Southern Ring Nebula captured by the JWST, they realized they needed to reconsider their assumptions about the unremarkable object. The Southern Ring Nebula, located approximately 2,000 light-years from Earth in the constellation Vela, is visible in the southern sky. JWST's predecessor, the Hubble Space Telescope, had previously imaged the nebula, also known as NGC 3132. However, Hubble's photographs, while stunning, failed to convey the full story of this dust cloud, which arose from the implosion of a dying star about 1 billion years ago. The Southern Ring Nebula is a planetary nebula which, despite its name, has nothing to do with planets, and is instead the result of a red giant star implosion. When a star slightly larger than the Sun runs out of hydrogen fuel in its core, it expands into a red giant, which can be hundreds of times larger than the original star. The red giant eventually sheds its outer layers and contracts into cooling remnants known as white dwarfs. Stephan's Quintet. Stephan's Quintet is a compact galaxy group 290 million light-years away in the constellation Pegasus, in the same patch of sky as the famous asterism known as the Great Square of Pegasus. This brand new image of Stephan's Quintet contains over 150 million pixels and was created by combining nearly 1,000 individual image files captured by the JWST. It was photographed with the telescopes NIRSpec and MIRI. JWST's stunning image depicts clusters of young stars and bursts of star birth throughout the galaxy group. While it may appear that the group's 5 galaxies are gravitationally bound, only 4 of them are. NGC 7320 is the 5th and leftmost galaxy, and it is much closer to Earth than the other 4 galaxies. NGC 7320 is approximately 40 million light-years from Earth, while the others are approximately 290 million light-years away. Carina Nebula. The Carina Nebula is a glowing cosmic cloud located about 7,600 light-years away in the constellation Carina in the southern hemisphere. It is a well-known and popular target for astronomers and astrophotographers, but none of them have ever seen it like this. The JWST captured this image of the Carina Nebula, NGC 3324, in infrared light, and it shows peaks of glowing cosmic gas and dust about 7 light-years high. The cavernous formation seen in this image is sculpted and shaped by ultraviolet radiation and streams of charged particles, known as stellar winds, emanating from hot young stars within the nebula. Tell us which of these images fascinates you the most in the comments section below.